Hello and welcome to Using Threat Modeling to Improve Compliance. I'm Adam Shostak, and before we get started, let me tell you a little bit about myself. I'm often known for having written a book on threat modeling, done a lot of work in threat modeling, including creating the Elevation of Privilege card game, advising a company, Arius Risk, that's in this space. I created earlier the Microsoft SDL threat modeling tool. I'm on the review board for Black Hat. I helped to create the CVE, and I run a little company that helps people improve the security of their systems. And so let me tell you what this talk is about. What it's really about is that compliance is painful for many reasons. The reasons that it is so painful, some of them are self-inflicted. Some of them are a result of engineering constraints. The standards have to be both precise and flexible. But almost no standard really starts with why in a meaningful way. And that creates a tremendous problem for all of us. And we're going to talk about it today. And I'll give you some examples, and then we'll close out by talking about how we can make it better for both companies and for standards bodies. So the way in which we're going to do that is we'll start out with some level set, understanding compliance. We'll talk about the PCI standard. We'll talk about threat modeling. I'll give you a quick introduction to it in case you're not familiar with how to threat model. I will show you a threat model that I created from PCI and explain how it relates to the standard. And then we'll talk about how to make the world a better place, one threat model at a time. So let's start out with compliance. And what I mean when I say compliance is work to demonstrably meet some standard. And in security, we often deride this as checklist security. Okay, yep, that's true, we do. But I believe we can do better than that. And that's really why we're here today, is to move beyond that checklist to something that's higher value. Now, compliance requires a standard. It can be set by law, something like the California Privacy Act, by regulation that comes from an agency, by industry practice, or by contract. All of these impose on you some requirement to comply with something. And these standards tend to be written by experts, and we'll come back to that. And lastly, they require some degree of assurance work, some demonstration that you're meeting the standard. Now, the PCI data security standard was created by the payment card companies, and it's imposed by contract before you can get paid by credit card. It's checked by these companies, these QSAs, these qualified security advisors. And let's be honest, arguments with your QSA are pretty darn common. And the PCI DSS standard has had a number of effects. Since it was promulgated, demands for new laws have fallen away, and this gives us some simplification. We don't have to worry about complying with one law in the US for credit card security, one law in the UK, one law in Germany, one law in China. We have a single set of standards that we can comply with globally, and that's useful. PCI assigns both liability and cost, and the people to whom it's assigned often don't like that. The last effect of PCI is the creation of new companies. It used to be 10, 15 years ago that small companies would process credit cards themselves, and that was a source of problem. Now, by and large, it gets outsourced to companies like Stripe and Square, who can make bigger investments in security to protect the card numbers. And that's an effect of PCI coming out and being imposed. I'm looking at PCI today because it's a useful example. If I were to talk about a medical device standard, many of you would tune out now. You're not in the medical device space. What does this have to do with me? So PCI is useful because it's broad. It's useful because it's broad. It's also a source of frustration. And lastly, it's useful because it is relatively freely available. There are many standards that you have to pay hundreds or thousands of dollars to get a copy of. PCI is not one of them. And what I'm going to say may sound like I'm here to criticize the PCI Council, and that is not my intent. Those folks have a hard job, and they're working to deal with the challenges that they face. And I'm using PCI respectfully because of its familiarity and its accessibility, rather than to be here to criticize the PCI Council. The things I'm going to point out apply to a great many standards because of the nature of standards. So, what is PCI? PCI, as you probably know, has 12 main requirements, like install and maintain a firewall and avoid default passwords. And it has 129 pages that look like this. And let's dig in. So this is our randomly chosen page of PCI. It's got 3 columns. You've got your description of groups you've got your requirements, for example, description of groups, roles, and responsibilities for management of network components, and documentation of business justification. You have testing procedures that are associated with this, and you have some guidance. And the guidance is the closest that we get to why is this here. And sometimes it actually comes pretty close. It's pretty explanatory. For example, on this page, we can see sort of on the lower right, compromises often happen due to unused or insecure services and ports, etc. This is the reason. This is the why, and it's not always present. This page happens to have it. So let me shift gears from here for a moment and talk about software development, the context in which the conflict occurs. And so if you're a software engineer, you want to be doing this work because you get to solve some customer problems, you write code, you build some cool stuff, you change the world. It's awesome. That's the ideal. That's why people get into software engineering. But in practice, what it entails is dealing with cost, risks, and mitigations, accessibility, compatibility, configurability, manageability, all of this stuff that we have to do. And by the way, this is from a product that I've worked on that you've used from the specification framework that every developer had to work on. It's not a random list that I created. And this stuff gets pretty overwhelming if you're a software developer. I just want to write some code. I want to build some cool stuff. And so what happens is that when the developer tries to work with security, security often acts as an inhibitor, a blocker. There's some standard that's put in the way of the work that they're trying to do. Why is it the standard? Well, it's the standard. You've got to comply. Comply now. And then they ask, why do I have to do that? And there's this bunch of folks over on the side here who are sort of anonymous. We don't know a lot about them. And there's this opaque stuff is happening in a standards process. And this produces a standard which sort of falls on the developer to go do. It falls on the ops engineer to go do. And I just want to write some code. I just want to develop my features. I want to get through this sprint's requirements. So compliance creates conflict. It creates conflict between security and operations, where operations wants to leave things open for availability or performance reasons, and security says, no, you have to configure this, and you have to configure that, and you have to check this. Compliance creates conflict with security priorities. There may be things that you, as a security professional here at the RSA conference, want to go do, but your time and energy is absorbed by the compliance demands. I'll tell you a little story. I was working on one of my startups, and I called Buddy, And I said, Dave, I've got this great idea. I'm really excited about it. I want to do this and that and the other thing. And he said, Adam, let me walk you through my budget. And he walked me through his budget sort of line item by line item. And at the end, he said, I have about, and by the way, he had a budget that was in the, I don't know, 8-9 figure range. And at the end of it, he said, Adam, I've got $50,000 of discretionary budget. Do you think this is the best use of it? I said, wow, I didn't realize your life was that constrained by compliance. I thought you had more discretion in what you were doing. But this is the reality in which a lot of us find ourselves, is these demands push priorities onto us that might not be the priorities that we think are the most important. But it's compliance first, right? It's table stakes. And this creates conflict within the organization because people have different goals, they have different prioritization, and you might say, we all work for the same company, but the bonuses are different. The developer's bonus comes from shipping the cool features. Security's bonus might come from not being breached. And that creates conflict in what we're trying to accomplish. Now, compliance is imposing these different goals. This can be important for an ecosystem like the payment ecosystem. It can be important for a society. For example, the way the Europeans have imposed GDPR because they say privacy is important to us as a society, even if your company has a different view, even if your company is somewhere else, you're imposing this on our European citizens. It's easy to lose sight of that if you're in the weeds. This never-ending stream of demands really draws us away from, yeah, there actually are reasons to do this. And so with that, let me build the next piece in our setup, which is an introduction to threat modeling. And I'm going to talk about threat modeling versus threat intelligence, because people often get a little confused there. And then I'll talk about what is threat modeling and give you a 2-minute introduction to how to do it. So, threat modeling versus threat intelligence. First, what do we mean by threat? In threat modeling, it's the promise of future violence. He said he would beat me up if I didn't give him my lunch money. There's a problem that the API could be overwhelmed by a brute force attack. These are promises of future violence. That's the meaning of threat in threat modeling. In threat intelligence, we're talking about attackers or attacker groups. Threat modeling often happens very early in the development process, sometimes before there's even a design, when it's on a whiteboard. Threat intelligence is once the system is built and deployed, we're finding attacks against it. The goal of threat modeling is to find issues. The goal of threat intelligence is to find attackers. And then the vendor support is very different. In threat modeling, it's consulting, it's training, it's software. In threat intelligence, it's much more focused around feeds of information. And so we're focused on threat modeling, that middle column. What we're going to do is apply threat modeling to compliance. And when I talk about threat modeling, there's a lot of ways to threat model, and I focus in on 4 key questions. Those questions are, what are we working on? What can go wrong? What are we going to do about it? And did we do a good job? And we can ask those questions at that incredibly simple level. We can apply tools, and I'll show you some in just a second, that help us think about each of these questions. But these questions allow us to be systematic in the way in which we think about the question of what are we working on and what can go wrong, so that we can be structured and comprehensive in the security design of our systems. And that is a really powerful tool set. It's why I do what I do, is because these 4 questions unlock a more strategic approach to security. So how do we do this? Often we'll use data flow diagrams to represent our systems. And for this talk, I'm not going to delve really deeply into what a data flow diagram is, but you'll see diagrams like this as ways to represent what we're working on. As we talk about what can go wrong, we often talk about STRIDE. STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. I say it a lot. And people will say the STRIDE methodology or the STRIDE taxonomy. It's not a taxonomy or methodology in and of itself. It's a structure that helps us think about the question, what can go wrong? And in doing so, we get to a set of things we're going to do about these threats. We get to a set of controls, to mitigations that help us address the problem. And so threat modeling works as a framework for thinking about the threats and how we deal with them that we can apply to compliance. So how do we do that? This diagram is something I created while I was working on my threat modeling book. And there's an interplay between each of the elements, the requirements, threats, and controls. So if we say, for example, we need to protect the confidentiality of a credit card number, then that can inform a threat. We're worried about the threat of information disclosure. Or we can go the other way. The threat can inform the requirement. If I'm thinking about a threat, say the threat that someone's going to walk through my front door, I have a control. I put a lock on it. And that control comes under threat. Someone could pick the lock, they could drill it, they could kick the door down. And so I could start by thinking about the control and what can go wrong with the control, or I can think about the threat and say, oh, I need a control here. And so there's a back and forth. And then we've got a dotted line from requirements to control. And when I talk about threat modeling, I'll often joke that the dotted line is there because it doesn't make a lot of sense. What's the point of a requirement to have a control if there's no threat involved? Sounds like a good definition of compliance. Ha 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 ha. Let's all poke fun at compliance. It's also sort of true. Funny, not funny. And this talk is really about this line and this relationship where compliance regimes require that we put controls in place without going through the threat. And I think that that creates needless conflict, needless ambiguity, needless anxiety, and leaves us less secure than we would be if we talk about the threat models. So what I want to do, and what we'll do in just a minute, is we'll take that opaque box that you saw, the stuff happens here box, and make it transparent. We'll make it more explicit. So let's go do this. Let's delve in and ask the question, what is PCI's threat model? And let me start off, and this was sort of a funny accident, and I'm really glad that the reviewer made this, one of the reviewers at the RSA conference made this comment in looking at an early draft of this deck. And they said, the standard is concerned with a single threat actor, generally sophisticated and motivated organized crime, wanting to affect a single factor, confidentiality, or a single asset, payment cards. And we'll come back to this because I think it illustrates a point really well. Before we get into what I'm going to say, what I'm going to show you is my best effort to understand PCI, but I don't represent PCI, I don't work for them, I'm not a QSA, so please, this is not official. Thank you for understanding. So what I went and did is I took my knowledge of threat modeling and I went through the PCI standard and I looked at each and every line and I said, what does this line mean? I'm going to imagine a threat here. And when I got to something like this description of groups, roles, and responsibilities for management of network components, I tried to integrate it into the threat list. I'm telling you this story politely. Let me tell you what I actually did. I jumped up and down and I yelled and I said, "This isn't a threat. What is this?" It was frustrating because this doesn't relate to that promise of a future problem. It's okay. So where does this play in? And so eventually what I got to was a realization that there are process issues and there are technology issues represented. And instead of just building out a threats list, I realized what I really needed was a set of models representing what PCI was thinking or what the PCI experts were thinking about. And so I started iterating on both those system models and a threats list. And that led me to something that I think is actually very interesting. And so the threats or the controls, the mitigations in PCI, the things you have to do, the answers to these questions of what are we going to do about it, that's part of threat modeling, are a broad set. They're prevent, detect, and respond controls. They're often threats of information disclosure, but they're also unusually threats to management or threats to the management of the system. They're not threats directed at management, or they're threats to our ability to comply with the standard. And this is an unusual thing compared to how we often threat model systems. As we ask what can go wrong, as we ask what are we working and what can go wrong, we don't often come to the answer. What can go wrong is lackadaisical management oversight or insufficiently applied processes. We much more often come to an attacker could send an exploit that takes over my computer, or the attacker could engage in a denial of service attack, et cetera, et cetera. And so the process model, which I created for PCI, is up on the top right. There's a set of change management activities. Some of these are interrupt driven. When this occurs, do this. Some of them are timer driven. Once a quarter, do that. And that feeds into a set of review processes, approval, and execution, which influences your technical systems. And there's a tracking database. You knew about that tracking database, right? But there's a tracking database where all of this stuff is supposed to flow to so that it can be audited. There's a set of standards. For system deployment, there's a set of standards. And those standards drive configuration and deployment. And the gray numbers, the C1, the C7, are system element identifiers to help us relate the tables of threats, which I'll show you in a minute, to the system models. So this is their process model. And this is their system model. And their system model starts with a credit card number over on the far left that talks to a point of sale system, which in their model connects via a wireless network to the card data environment. That trust boundary with the 8 CDE in it is where all the processing happens. And then from there, data flows out to an acquirer. Credit card jargon, the acquirer is the bank that acquires the charges from a merchant and sends them to the issuing bank that gives you as an individual your credit card. And so this is and again, we've got the gray numbers here. And I did this model first before I realized we also needed a model of the process. And based on these models and based on the standard, we can create a set of threats to processes. So for example, we've got a threat that the firewall rule set will go out of date. It's a management threat. And this is a threat which is addressed, controlled, mitigated by PCI requirement 117. There's a threat that old data isn't deleted, which is covered by 3.1 bullet 2. And so we can go through the PCI standard, and I'll give you a link at the end, by the way, to this whole set of lists. But right now, I don't want to focus on a line-by-line analysis in the interest of time. What I want to say is we have threats to process and we have threats to technology. And a couple of interesting things come out here. One is that in the PCI standard itself, there are no threats to your credit card. Your credit card in your wallet is not something that is addressed by the standard. Come back to that. The other thing that came out, I was talking to someone about this work, and he said, storing authentication data isn't a threat. I said, you're right, it's not. It's an enabler of a future problem. If you don't store the data, you can't leak it. And so PCI's approach is a little unusual in that they consider the storage to be the problem. It's a violation of the requirement, even if it never leaks. And getting to that understanding helps us understand the why behind PCI so that we can actually address it better, so that we can communicate with our colleagues when there's conflict over what we need to do and why we need to do it. So let me come back to what that reviewer said. And what they said was that the PCI standard is about a single factor, confidentiality. And it turns out when we go through this exercise, integrity is important, auditability is important, repudiation is important. And I was talking to a friend who's close to the whole process, and they told me that actually, the logs are not there for the victim of the break-in. They're there for the card companies. When they go in and do an analysis of the big breaches, they were finding a lack of logs. And that didn't even come out as I was reading the PCI standard. It came out of a later conversation. But it's important to understand why we're storing and protecting these logs in this way. The other thing they said, the other thing the reviewer said, is that the standard is concerned with a single threat actor. That's not something that I saw reading the standard. Now, does that matter? Well, if we're trying to reduce conflict and help people get value out of doing this work, then the problem is not me disagreeing collegially with a reviewer. The problem is that we have that space in which to disagree. The opportunity for disagreement between myself and one of the smart folks who serves as a member of the RSA Conference Program Committee, that is a problem. We as smart people ought to be in agreement about what it is we're doing. And so, I believe that we can improve security by your organization doing better threat modeling. By definition, outside standards are not going to address your unique needs. You've got a whole bunch of standards that you have to look at. You have to look at PCI DSS. You have to look at the NIST cybersecurity framework. Some are very specific, some are very broad. If you pick up all of these standards and you threat model and you say, these are the threats we're going to address, you get to the point where you can be structured, systematic, and comprehensive in what you address, and then you can tie your mitigations back to the standards. And this is really important in limiting the runaround, limiting the treadmill that you're on by understanding where you're going. Threat modeling shines a light into this opaque box. And in shining that light, what we do is we improve security because we're focused on the threats and we're focused on making sure we're not just picking up controls and slapping them in, but we're picking up controls and using them to address an understood threat. We're using them to mitigate a real problem. This informs our prioritization, which of these we do first. It can also reduce conflict between teams, reduce conflict with auditors, maybe, but it's a lot of work. So the conflict comes from different goals and different priority. And when compliance is imposing these new and different goals, there's no understanding of the why. Threat modeling gives us a language. What are we working on? What can go wrong? The line-by-line controls that the compliance standards demand of us are informed by this joint understanding of what we're working on and what can go wrong, and therefore what we need to do about it. So threat modeling also gives us a vehicle to create collaborative spaces. And here the journey is really the reward. I want you to think about threat modeling more than I want you to think about threat models. And I want you to think about these in terms of teams working together across organizational boundaries to generate this shared understanding and a space for listening to the concerns of the other teams. Look, I get it. Security teams are almost always too busy. It's hard to make the time to listen, but listening is so important. It creates space for the people you're working with to help you discover solutions, to make smarter solutions to the problems that are in front of you. And when you found that solution together, there's joint ownership of what the solution is and why you're doing it. And so security gets built in, not bolted on. It doesn't get left behind on the shelf because you made time to listen. So I also think that there's work to be done by standards bodies. Why is every organization doing this analysis? This was really hard work. This was challenging work. I think we ought to demand that standards bodies show their threat models. And I'm talking to some, and I'd be happy to talk to more about exactly how to do this. This will improve the standards. It will improve the impact of the standards, because when their model doesn't represent your system, it's more visible. And so the controls are going to get adjusted, they'll get invalidated, and that creates some tension that we need to deal with and think about intelligently. There's some complexity here. People might game the standard. The cost of assessment will change. We'll need to retrain the assessors about what to do in these situations, but that's worthwhile. So again, the review process was really interesting. One of the reviewers asked, can we create a single threat model independent of details? Well, it's a great question. But the one-size-fits-all PCI standard covers the very largest e-commerce stores. It covers a very small retailer using something like Shopify. It covers a brick and mortar store. And so my answer to the reviewer who asked this great question was, yeah, the PCI standard says they've created a single threat model independent of these details. And I think that that has created some problems. So some short-term wins. Go learn a little threat modeling. I'll talk about how on the next slide. And I want you to focus in on what you're working on right now. What are the CEO's key priorities? And frankly, today in 2021, that is pandemic and coming out of the pandemic. Focus on things that are being changed right now, because that is where the fluidity exists. It makes change easier. There's a trap of falling into the high risk areas where you've been fighting. Don't go there. You will mess up your threat modeling initiative before it starts. Go to what is being changed now and use threat modeling to frame a new conversation. When we learn to threat model, the 4-question framework, what are we working on? What can go wrong? What are we going to do about it? Did we do a good job? Is super useful. Elevation of Privilege is a card game I created. Microsoft has released it under a Creative Commons license. You can buy copies on Amazon now. Use it as a conversation starter. Lastly, a group of 15 of us experts in threat modeling have released a manifesto, which is all about how to get going. The 4 questions there, they're so simple, they fit on a wallet card. They are the way to get started. So go learn threat modeling. In the next week, go build some threat models. Demonstrate that having threat models helps, share them out, showcase these new ways of working, and demand that your standards bodies show their threat models. And that is going to take some time, but it's a worthwhile thing to go invest in. With that, I want to say thank you. If everything went as planned, I've been answering some of your questions in the chat box here. If you're watching this later on, my email address, adam@showstack.org, is right there. And so, again, thank you for your time and attention. I want to close out with some resources. Again, the manifesto, my threat modeling book website has a set of free resources. There's Elevation of Privilege links and copies of it on GitHub. Last but not least, on associates.showstack.org/threat modeling is a copy of a white paper I did freely, no reg wall, that shows this PCI threat model that we've been talking about. So with that, again, thank you for your time and attention, and have a great day. Thank you.